homework in order to solve it. Now you tell me, see what we can do in order to getting standard cell potential for Fe plus 3 to Fe. So what you can do? What is given to you? Fe plus 3 is reduced to Fe plus 3 is reduced to Fe plus 2 by gaining 1 electron. This is given reaction. This one. And its cell potential is also given 0.771. So you can have a here free energy change. You can say delta G1 is equal to minus NFE cell. So here delta G1 is nothing but minus 1 electron is there for this reaction. So it's a 1 F. E cell value is given 0.771. So you can have a 0.771. That is your answer, minus 0.771 F. Delta G1. Second reaction given to you is Fe plus 2 is converted to Fe, where 2 electron gets abstract and it is converted to Fe. This is also reduction one. So you can have a delta G2 is equal to minus NF cell is equal to minus N is equal to 2 F. This cell value become 0.44. It's minus 0.44, this one. So it become 0.88 F. Good. What is your target is to calculate E cell for Fe plus 3 to Fe. Now, how to getting this reaction, this equation from above to by subtraction or by addition? What happens? What you can do? This is 1 and 2. What you can do in order to getting this equation? For this equation, see delta G is equal to minus N F E cell. E cell we are going to calculate. So N is equal to 3. Now how to getting this one? This equation? Here you need 3 electron. આ બંનેનું subtraction કરતા મળશે કે summation? Summation. Because you require 3 electron. So 1 plus 2, it's a 3. So Fe plus 3 plus Fe plus 2. If you do the summation of these two, so this become Fe plus 3 plus Fe plus 2. Or you can say Fe plus 2 is cancelled out on both the side. Left hand side and right hand side. So 3 plus 2 plus 1, that is 3 electron. Gives Fe. So therefore summation is there. So delta G is equal to delta G1 plus delta G2. Delta G is nothing but minus 3F E cell is equal to delta G1 is minus 0.77F. Delta G2 is 0.88F. So overall FF is cancelled on both the side. Minus minus 3 cell is equal to 0.77 and a 0.88, that is 0.11. So each cell is equal to minus 0.11 by 3. So 4 3 बार है, almost it's a 0.04 something. This become your answer. Okay. Is it clear? This become your answer. So in this way you can calculate E cell value. I think it is clear to all. Okay, so whatever the problem is there related to cell potential, so that is we have completed. Now we go for very important equation that is called Nernst equation. It is one of the important equations, Nernst equation, especially for electrochemical cell, how to write down Nernst equations. So we will focus on that one. And many times this equation is asked in a 4 marks or in 2 marks in net exams by given different modified form. So what is Nernst equation? So Nernst equation is nothing but relationship between cell potential, standard cell potential, and concentration. This is written for reduction reaction. Suppose this is your reduction reaction, any reaction which gain an electron to gives metal. So in this case, how to write down Nernst equation? So see, each cell potential is equal to the standard cell potential minus RT upon NF ln concentration of product, that is M solid form, divided by concentration of reactant upon concentration of reactant. So see, this is in solid form product is, so its concentration is taken unity. So you always take, see, this is in solid form, so its concentration is unity. Suppose see, copper plus 2 is reduced to copper, then how to write down this equation? So it is simply copper plus 2 to copper half cell potential is equal to standard half cell potential minus RT upon N is equal to 2. 2 electron gets exchanged, so it's a 2F ln 1 upon copper plus 2. See here, copper is there in solid form, so its concentration is taken unity. Copper is in solid form, so its concentration is 1 molar. And here it's a copper plus 2, so it's a, you can write down. It is its concentration of copper plus 2 as it is, but copper is there in solid form, so its concentration is unity. This is the value of standard cell potential. Similarly, another reaction is Zn, reduction of Zn plus 2 to Zn. Suppose if you want to write down same for this one, then you can write down in this way. So complete cell reaction can be written as this way. E cell is equal to, see, we want, this is our cathode. This is nothing but cathode. And this is anode. So we want total cell potential is equal to E cell at cathode minus E cell at anode. So here we can write down E standard. That is cathode minus anode. That means equation 1 minus equation 2. Now minus RT upon 2F minus RT upon 2F minus minus plus. This become plus. This is ln minus and this is ln plus. So you can say, or you can write down in simple form, no problem. See, first in the first term, you can take a minus RT upon 2F common, or you can write down the first term here. It's a minus RT upon 2F equation number 1. ln 1 upon copper plus 2 plus RT upon minus minus plus second term. Now in order to make first term, see, in both the term my RT upon 2F is common. Suppose you can take minus RT upon 2F common, then in the bracket this become plus ln 1 upon copper plus 2 minus ln 1 upon Zn plus 2. And you know that, see, subtraction is there. So in logarithm form, it become equal to dividation form. Minus RT upon 2F ln 1 upon copper plus 2 divided by 1 upon Zn plus 2. Divided by 1 upon Zn plus 2. છેદનો છેદ છે ઉપર લખાશે. So it become E cell is equal to E standard minus RT upon 2F ln Zn plus 2 upon copper plus 2. That is anode upon cathode. This is your Nernst equation. This is Nernst equation. You know that, see, how to write down overall reaction from these two. So this become overall reaction for Nernst equation. Zn is oxidized to Zn plus 2 and copper plus 2 is reduced to copper. So this is your product, and this become reactant. So you can write down E cell is equal to E standard minus RT upon NF. ln પ્રોડક્ટ અપન રિએક્ટન્ટ પ્રોડક્ટ કોપર છે સોલિડ ફોર્મમાં છે એનું કોન્સન્ટ્રેશન 1 મોલર થઈ જશે Zn+2 અપન Zn સોલિડ ફોર્મમાં છે એનું કોન્સન્ટ્રેશન 1 મોલર કોપર +2 so that is nothing but the product upon reactant. If you put a value of R is 8.314, temperature is 298 Kelvin, and pressure with 1 atm pressure, 1 atmospheric pressure, and you can have a F is equal to 96500. Put all the value into this equation, then you are getting a simple form, that is E cell is equal to E standard minus 0.0592 upon n log. Now ln is also converted to log by multiplying with 2.303. This is also, you can say, Nernst equation. Or see any reaction, for example, see this is your reaction. A moles of A react with B moles of B to give product C moles of C and D moles of D. Now how to write down Nernst equation for this one? So E cell is equal to E standard minus RT upon NF log product upon reactant, that is called quotient. Quotient C is defined. Quotient C is nothing but concentration of product, that is C into D. ના મોલ છે ને ઘાતાંકમાં લખવાના divided by reactant. So this is the way you can write down the quotient. See, for any cell, what happens at equilibrium? At equilibrium, whenever the equilibrium condition is given, at that time at equilibrium, you always write down C cell value 0. When cell is in equilibrium, then cell potential becomes 0. So you can have this equation. Minus 2.303 RT टू पॉइंट थ्री में एटला लेखा है ln ने log में कन्वर्ट कर दो इट्स अ log कैसे now we can put equilibrium constant if cell is in concentration cell. What is definition of concentration cell? This is very, very important. cell with same electrode, anode and cathode બંને electron same જ હોય, but having different concentration. Is called electrochemical cell. Sorry, concentration cell. Same electrode હશે, so standard cell potential anode અને cathode બંને સેમ જ રહેશે, but sign different હશે, એટલે ઈ standard cell જે છે એ 0 થઈ જશે. For this cells, standard cell potential is equal to 0. કારણ કે એનોડ માઇનસ કેથોડ કહીને આપણે કેલ્ક્યુલેટ કરીએ છીએ, બંને સેમ જ છે અહીંયા, એટલે બંને વેલ્યુ સેમ રહેશે, so difference become 0. So this is, you can write down for electrochemical cell. Two other equations are also there that we are going to use. One is already we have used. Delta G is equal to minus NF E cell. એક આ equation નો use કરશું. Second one is delta G is equal to minus RT upon RT ln K. Equilibrium constant આપ્યો, જ્યારે આ બંને equation પણ Nernst equation સાથે correlate કરીને use કરવાના. So that is very important equation. ચાલો, up to here anybody have any doubt? Each and every point of this chapter is very, very important. Now up to here, is there any doubt? અહીં સુધી કોઈને કોઈ doubts હોય Nernst equation માં, so you can ask me. Otherwise we can go, we are go for, we will take its application part.
No, sir.
Okay. So applications of Nernst equation, say how, which type of question is asking to you. So first question, see, first I go for already questions there was asked in net examination. We are going to solve it. Which one of the following is which one is correct Nernst equation for redox reaction this one. Now you tell me the correct answer. This is first option. This is second option. This is third one. Third one, that is E is equal to E open R is equal to E raised to now you tell me which one is correct. According to you, which one is correct?
Third one, sir.
Third one.
Sir.
Let me check it. How to write down Nernst equation for this one? First, E cell is equal to minus. So the E cell is equal to E standard.
E0
E0, good.
minus RT by NF ln R by O.
E0 minus RT by NF ln R by O. Product upon reactant. This become your product. This is the reactant. Okay. Now you want O by R. See, first equation is not matched with this one. See, first equation O upon R. Say we want C, and in our case it is R upon O. So first option to આવશે જ નહીં. Now next you go for to make O upon R is a subject of formula. બાકીના ત્રણ ઓપ્શનમાં O upon R છે જુઓ. O upon R ને સબ્જેક્ટ ઓફ ફોર્મ્યુલા બનાવો છે. So E is equal to E standard minus જે છે એને હું પ્લસ કરી દઉં. And denominator and numerator જે છે એને આપણે opposite કરી દઈએ, ઉલટાવી દઈએ. Denominator become numerator and numerator become denominator. એટલે લોગારિધમમાં બંને અંશ અને છેદ ઉલટાવો તો માઇનસ જે છે એની જગ્યાએ સાઇન પ્લસ થઈ જાય. Now RT upon NF ln O upon R એને સબ્જેક્ટ ઓફ ફોર્મ્યુલા બનાવીએ. આ ટર્મ સામે જશે, so it become E minus E cell.
E0.
Okay. Now next you can go for ln O upon R. So NF જે છે એ છેદમાં છે, અંશમાં જશે, અને RT જે છે એ છેદમાં આવશે. હવે આનો ln જો અહીંયા રિમૂવ કરવો હોય તો સામેની બાજુ એક્સપોનેન્શિયલ લેવો પડે, બંને બાજુ એક્સપોનેન્શિયલ ટૂંકમાં. So it become E raised to NF upon RT E minus E cell. This is your correct Nernst equation. Which one is correct one? કયું correct છે option?
Second.
Second one. So second one is the correct one. Similar another questions that is asked in 4 marks is if the ratio of composition of oxidized and reduced species in electrochemical cell is given as oxidized and reduced species. So this is given to you. E raised to 2. The correct potential difference will be which one is correct?
E.
Now we check it. So equation become E is equal to ACl minus RT upon NF ln oxidation upon concentration of anodic species upon cathodic or oxidation upon reduction. This is your Nernst equation. Now you can put the value. See, you are given oxidized to reduced species concentration is exponential s to 2. The power છે એ આગળ આવશે exponential s to 2 જે છે 2 આગળ આવશે અહીં ln છે ln અને exponential opposite હોય એટલે રિમૂવ થઈ જશે અને 2 આગળ આવી જશે so it become આ રીતે આવશે so e minus e standard is equal to minus 2RT upon NF. Now which option is correct? Which one is correct?
B.
So B is correct one. Another same question, same type of question is asked in SLATE exam. That is, at pH 2, if standard cell potential for queen hydron is equal to 1.30 volt, this is hydroquinone and this is quinone. Both are in solid form. This is aqueous form. Then E queen hydron, that is cell potential of queen hydron, will be like, this is the question, 1.36 1.30 1.42 D 1.20. How to write down Nernst equation? First of all, tell me the way to write down Nernst equation is equal to E is equal to the cell minus RT upon NF ln અને ln ના લખવું log લખવું હોય તો 2.303 log લખો ln ની જગ્યાએ. log પ્રોડક્ટ upon reactant, પ્રોડક્ટમાં એક H પ્લસ છે એનો પાવર 2 છે, બીજું ક્વીન હાઇડ્રોજન છે, ક્વિનોન, ક્વિનોનનું કોન્સન્ટ્રેશન 1 મોલર આવશે, સોલિડ ફોર્મ છે એટલે ક્વીન હાઇડ્રોજન એનું કોન્સન્ટ્રેશન પણ 1 મોલર આવશે, એ પણ સોલિડ ફોર્મ છે. So equation become E is equal to E standard minus RT upon NF, N is equal to 2, F 2.303 log H plus square. આ વેલ્યુ જે છે RT ને બધી મૂકી દેશો એટલે it's a 0.0592 upon 2 અને અહીંયા 2 પાવર્સ જે છે એ આગળ આવશે, it become log H plus. Two cancel out, so E minus E is equal to E standard minus 0.0592. Now see minus, what is given to you? It is pH. And definition of pH is minus logarithm of H plus. This is called pH. This is your pH. So minus logarithm of H plus is pH. That is, value is given into 2. pH value is 2. That is pH equal to 2 is given. E standard is also given 1.30 volt. So what is E? This is 1.30 plus 0.0592 into 2. So it become 0.11 something. It become 0.118 something. So your answer become 1.418. It is close to 1.42. So this become correct one. This is correct one. Is it clear? આમાં કોઈ ડાઉટ છે?
No, sir.
Okay, fine. Fe to Fe plus 2. Its concentration is x molar, which is in connected with copper plus 2. To copper, its concentration is 0.01 molar. Which one is anode and which one is cathode? E cell is also given. Reduction potential of both is given. કયો anode છે ને કયો cathode છે બોલો?
Fe anode છે સર.
Cu cathode.
લેફ્ટ સાઈડ લખીએ શું હોય? Fe માંથી Fe plus 2 થાય, copper plus 2 માંથી copper, આ રીતે આપણે આપેલ છે. So anode may undergo Zn to Zn plus 2 and copper plus 2 to copper, આપણે લખતા હતા ને એ રીતે જ જવાનું. So Fe become anode and copper become cathode. Good. Right side હોય એ cathode હોય, left side હોય anode હોય. So Fe plus 2 to Fe and standard reduction potential is given minus 0.44 volt. Copper plus 2 to copper, its reduction potential is also given 0.34 volt. આના ઉપરથી પણ ખ્યાલ આવી જાય કે એનો રિડક્શન પોટેન્શિયલ વધારે હોય એ કેથોડ હોય, ઓછો હોય તે એનોડ હોય. So question become, what is value of x? X is greater than 0.01 molar concentration. x is less than 0.01. Now which one is correct one? How to solve it? So see, for this you can go for this equation. E cell is equal to E standard minus 0.0592 upon n log anode, that is Fe plus 2, upon cathode, that is copper plus 2. N is equal to 2 electron gets exchanged. So you can take 2. E cell is standard, you can calculate using this formula. E reduction at cathode minus anode. Cathode become copper, so 0.34 minus 0.44. So total it become 0.78 volt. So you can put into this equation. E cell is already given 0.78 minus I upon 0.78 is standard. .78 આ બાજુ આવશે તો 0 થઈ જશે. Fe plus 2 નું કોન્સન્ટ્રેશન x આપ્યું છે. કોપર પ્લસ 2 નું કોન્સન્ટ્રેશન 0.01 છે, એટલે 10⁻². આ 2 0 ના મલ્ટિપ્લિકેશનમાં આવશે તો 0 થઈ જશે. 0.0592 એ પણ છેદમાં જશે તો 0 થશે. એટલે log x upon 0.01 is equal to 0. અને આપણે આમ પણ લખી શકીએ log x minus log 0.01 is equal to 0. So log x is equal to log 0.01. So x is equal to બંને બાજુ કમ્પેર કરશો તો ખ્યાલ આવશે 0.01. log બંને બાજુથી રિમૂવ કરશો તો. So this one become correct answer. This become correct answer. One more questions. I think this is actually question from 12th standard book. So you may need calculator, but in net exam it is not permitted. So તમારે જે cancel થઈ જાય કે solve થઈ જાય એવા જ આપે. So find out the value of equilibrium constant. When cell potential of shall become this is the cell Zn to Zn plus 2. Its concentration is 0.01 molar, connected by salt bridge Fe plus 2 to Fe with concentration 0.001 molar. Options become 10 raised to 0.3201 upon 0.0296. Now you can try yourself in homework and tell me the answer in the next lecture. You can tell me your answer in next lecture. So up to here, we can stop here. Thank you very much.